All right, section 7, negative exponents. Let's go. Okay, so how are these related here? So if I looked at this and I say 2 to the 6th is 64, 2 to the 5th is 32, 2 to the 4th is 16. Each time I'm going down here, how are these related? Well, 64 to 32 would be divide by 2. So this one's going to be divided by 2. If we do this one here, we're going to divide by 2. This one, divide by 2, and so on and so forth. Where it gets complicated is these last two. So when I go 2 over here, if I'm going to take 2 divided by 2, that comes out to 1. So 2 to the 0 is going to be 1. So then if I go 2 to the negative 1, I'm going to divide 1 divided by 2. So that would be 1 divided by 2, which is actually 1 times 1 over 2. So my answer is going to actually be 1/2 is going to be the next one. So technically, I guess you could say all these are times 1/2, times 1/2, times 1/2. So extending the pattern on the right shows that 2 to the first can be defined as 1/2. You can apply the quotient power rule as a definition of the power of x over 3, x over 5 to kind of write a general rule about negative powers, because once we get to negative, now all of a sudden it's an over something. So you can apply that general rule here. So here's two ways to kind of do this. You could go x to the third minus 5 would actually be x to the negative 2. That's one way to do it. Or if you look over here, you have, if you space them all out, put all the x's out, 3 on top, 5 on bottom, I cross out the ones I can't use, or the ones that cancel each other out. So it ends up being 1 over x squared. So since that can't have two different values, we can conclude that 1 over x squared and x to the negative second is the same thing. So here's that in a lot less words. So negative exponents for whatever the base to the negative n, or to the negative exponent n, is the same as 1 over a to the n, as long as it's not a 0, and the n has to be an integer. So example this. So that's kind of a quick why this works. All right, so write 3 to the negative 4 as a positive exponent. Well, using what we just learned here, the definition of a negative exponent is 1 to the negative 4, or 3 to the negative 4th is equal to 1 over 3 to the 4th power. So our answer is going to be 1 over 3 to the 4th power. Right, write m to the negative second as a positive exponent. So we don't want the negative exponent in there. So we're going to use that definition of negative exponents to convert negative to positive over, or as the denominator under 1. So there's our answer. All right, try these in your notes. Go. All right, so 5 to the negative third is going to end up being 5 to the third over, or under 1. So 1 over 5 to the third. This is going to be 1 over y to the 6th. All right, write this as an expression using a negative exponent. So now we're going backwards. So first we have to find the prime factorization of 125, which is 5 times 5 times 5. So we would probably have to use a factor tree to find that. So as a definition of exponents, we can say that 1 is 1 over 5 to the third. Now to make it a negative exponent, we're going to use the definition of negative exponents to flip that over and have a negative number there instead of a fraction. All right, you try. All right, so I'm going to I have to figure out what the prime factorization of 32 is. So 32 is going to be 16 and 2. Also, it's going to be a lot of 2's. 2 and 8, and that's going to be 3 2's. So 2 to the 5th So it's going to be 1 over 2 to the 5th. And then we flip that to equal 2 to the negative 5th. Right, an atom is an incredibly small unit of matter. The smallest atom has a diameter of approximately 1 over 10 th of a nanometer, or 0.00000000001 meter. Write that decimal as a fraction and as a power of 10. All right, so first we have to take that and put it as a fraction. So you have to count up all these zeros and put them over here. I think it's 1, 2. So there's 9 of those. So to write that as a fraction, then we're going to make that a power of 10. It's 10 zeros, 10 to the 10th. So definition of negative exponents. There we go. So 10 to the negative 10th. All right, you try it. All right, so to write it as a fraction, I'm going to have to go 1 over, let's see how many decimal points I have to move this. Let's go 1, 2, 3, 4, 5, 6. So 1 over 10, 1 with 1, 2, 3, 4, 5, 6 zeros. So this is going to be 10 to the 1, 2, let's see, 1, 2, 3, 4, 5, 6, 10 to the 6th. So it'll be 1 over 10 to the 6th, so 10 to the negative 6. I think. We'll see if I counted everything up right. Yes. All right, evaluate r to the negative second if r is negative 4. All right, so first we're going to replace r with negative 4. So negative 4 to the negative second. So we're going to flip it first so that we can do the multiplication down there. So negative 4 is going to be, negative 4 times negative 4 is going to be positive 16 since it's a even number. And a negative here, if this is even, then it's going to stay even, or it's going to stay positive. If it's an odd number, then this would be a negative number. So 1/16. You try. All right, same concept. So I'm going to take 5 to the negative third. So I have to flip that. It's going to equal 1 over 5 to the third. 5 to the third is 20, or see, 5 times 5 is 25, times 5 is going to be 125. It's going to be 1 over 125.